Hi boys and girls. So in the last video I told you about the probability of error. I told you about the signal transmission, the binary signal transmission, um, and the probability of error in that, and you understood that it's a Q function of the Q of d by 2 sigma. Now this baseband transmission is used for limited applications like land transmission or something. Otherwise, you go with the modulated systems, as in the case of mobile communication and all. And in this presentation, I will tell you about the need for digital modulation. So let me welcome you all to this presentation. Now, what you will learn in this short video, you will learn why I cannot send a discontinuous signal through an antenna, and then you will need the need for digital modulation, and then you will learn the names of different digital modulation schemes. Then if I look at the limitations of baseband transmission, you can see that in the baseband transmission of digital signals, they are convolved with a pulse shape GT, that is a transmitter filter. They are then sent over an AWGN channel. You know why the communication channel is Gaussian, white, additive, etc. We discussed in the previous sessions. And the train of pulses encounter both ISI, the intersymbol interference, and AWGN. But these short pulses cannot be, these sequence of pulses or trains of pulses cannot be used for long distance transmission, especially through an antenna. So an antenna is a very important component in any communication system. Any communication system invariably has an antenna, both transmitter and receiver antennas you have. So, but discrete pulses cannot easily be sent through an antenna. Why? Because the spectra of discrete pulses like square pulses are very narrow, and they require impractically big antennas. And if you look at say look at this picture, the top figure shows a rectangular pulse. The red curve shows a rectangular pulse. It's a fairly wide rectangular pulse, and its spectrum is plotted below. An approximate spectrum is plotted below, and you can see that it's a very narrow spectrum, which is nothing but a sin square function. And you can see that the spectrum spans over a very short band of frequencies, making lambda, which is C by F, very large. And antennas are of dimension lambda, like some antennas may be lambda by 2 in length, some may be lambda by 4 in length, some may be order of the lambda, some like paraboloid type antenna can be 20 times lambda, 10 times lambda. Anyway, the dimension of the antenna is in the order of lambda. So if I use a square pulse or discontinuous signals, then the spectrum being very small, the antenna becomes very large because the operating wavelength becomes very large. So unless the pulses are very narrow, very short, as in a pulse radar, it is nearly impossible to transmit discrete signals through antennas. Only in one case you transmit a pulse through an antenna, that is in the case of a pulse radar. There you use a very short pulse and a very big, gigantic, immobile antenna. But in practical cases like mobile transmission or something, we cannot use such antennas or such pulses. So, but continuous sinusoids of sufficiently high frequency, they are easily sent through the antenna. So digital signals are ultimately made into continuous sinusoids prior to transmission by digital modulation. So ultimately, if you look into a digital modulation as a block, you can see that the bits or the digital signals or the bits streams of bits are coming in, and out goes continuous sinusoids modulated in frequency or phase or amplitude. So these digital modulation signals are also called shift keying schemes. So ultimately, in what we do is we do all process in digital format or binary format. At the time of transmission, we map these bits into continuous sinusoids. So these are the different types of shift keying. One is amplitude shift keying or ASK. If that is the modulation is done in amplitude of the carrier, that is, if the incoming bit is at 0, then carrier is the sinusoid is transmitted with one amplitude. If the bit is at 1, you use another amplitude. So you switch between amplitudes. Say if the bit is a 0, you transmit with one amplitude, or if the bit is a 1, another amplitude is sent. Or else there is something called the frequency shift keying. That is, if the incoming bit is at 0, then the carrier is transmitted with a certain frequency. If the bit is a 1, then it is switched to another frequency. Say for 0 you use one frequency, say F1, and for 1 you use another frequency. So you switch an oscillator between two frequencies, or switch a frequency synthesizer between two frequencies depending on the incoming bit. And the third method, that is the most popular scheme, that is a phase shift keying. If the PSK, that is, if the incoming bit is at 0, the carrier sinusoid is transmitted in a certain phase. If the bit is at 1, then another phase is used. Okay. For the bit 0, you use one phase, and for the bit 1, you use another phase. So one simple scheme of that is the binary phase shift keying scheme, which is very popular in mobile communication. That is, if say the bit is 0, the carrier is sent with, say, 0 phase, and if the bit is a 1, the carrier is transmitted with phase 180 degree or pi, or that is, it's out of phase. So if it is a 0, you transmit with a 0 phase. If it is a 1, you change the phase, you invert the phase. So this PSK is the most widely used scheme, especially the BPSK, that is popularly used in mobile communication. All your mobile phones, they use BPSK modulation. Now, when I summarize this video, what you understood in this video, or you understood why discontinuous signals cannot be transmitted over antennas. Then you understood the need for digital modulation. Then you learn the names of digital modulation schemes. And that's the end of this video. I thank you very much. Bye bye.